Hello. I want to tell you about a concept that I thought up and just explain the basic idea behind it. The idea is that a metal ball will roll inside a tube, torus, and create air pressure or gas pressure. So if the ball is spinning in this counterclockwise direction, then air pressure will build up in front of the ball, and this air pressure will then cause the air to move out to the inside through one-way valves or non-return valves. So these little tubes with arrows represent the non-return valves. So as the ball spins continuously in a circle, the pressurized gas in front of the ball will cause the gas to move out of the successive valves towards the inside, and as the ball moves past the valve, there is a vacuum, or there tends to be a vacuum created behind the ball, and then gas or air is sucked in from the outside through a corresponding non-return valve from the outside of the tube or torus. So the idea was that if I could spin this ball or get it to spin fast enough that the pressure differences would be great enough that a sufficient amount of gas would be pumped from the outside in through these valves, and then one could pump gases, including air, and perhaps use this device in some efficient way. I was hoping that just because this is some new idea, that it might be beneficial in some other way where current gas pumping technology is perhaps not as efficient. So these things here represent copper coils which are energized, and perhaps you could see here that I've got there's a positive and a negative, so some current would flow through these and then creating electromagnetic effects to pull this ball, and they would then switch consecutively in a way that this ball would then spin. So one would need a controller to switch these coils to get the ball to spin, and then once the ball is spinning, the gas is pressurized and the gas flows, which is controlled through these one-way valves. So here I ordered a lot of them, and they're quite small. I mean, you can, relative to my hand, you can see how small they are, but this was specifically for the small prototype that I built, and they had to be very small, so they are quite specialized and quite expensive. And I ordered those with the that require the least pressure to operate, because I wasn't sure how much pressure I would be able to generate with this idea. This is then the prototype that I asked the electronics engineers to build for me. Well, actually, this wasn't my original design, just the concept is mine, but they suggested we use 4 coils instead of the 12 that I suggested, because the 12 would be harder to control and it's apparently not necessary. And so actually they did show me that they could get the ball to spin, and apparently they got it to spin at a maximum velocity of 600 revs per minute. I was actually originally hoping for something like 6,000 RPM, but they said that even to get the 600 RPM required a great deal of power, and actually the power requirement is the big problem with this idea, according to the engineers. And that is why this concept might not work the way it is, and it might take some other insights or a few years to get this idea to work properly with respect to power usage and power requirements. Here you can see sensors at these fasteners. At each coil is a fastener, and there's sensors going into this fastener, and just in front of that is another sensor. So what happens is, as the ball spins, this optical sensor senses that the ball is here, then a signal is sent to the transistors to power the coil just in front of it, and when it reaches these sensors just in front of the coil, then it switches the power off again, because if it didn't switch it off, the ball would get stuck at this coil. So as it reaches the coil, the power switches off and the ball keeps on rolling until the next coil. The basic problem here was that the power requirement was much too high, and this is why the concept doesn't work. One requires something in the order of 20 amps to power these coils, and the problem with efficiency is that most of the flux leaks out towards the outside of this tube, and where it's not actually used at all, and in fact it's only required inside the tube, but how to concentrate it inside the tube is the big question. I don't know how to do that yet, and perhaps you can think of a better idea that will make the whole design much more efficient. These are the little non-return valves. So the idea was that at every few centimeters there would be a pair of these, and as the ball passes one pair of valves, the gas would be sucked in and pushed out to create the effect of a pump. So even with a 600 RPMs, I could have tested the idea with the valves. Then I would have to rebuild the whole prototype again, because this one has holes, so it's not airtight and it wouldn't work to test the gas flow. And given the problems with the prototype, I'm not willing to rebuild the whole thing. Oh yes, I wanted to show you the ball. So basically that is the ball. That's what this is basically just a steel ball that I got at my local steel supplier, and it rolls in this PVC tube. So to finish the talk, the problem is with this design is apparently that it is very inefficient, and so the basic idea might work, but there'll have to be a large amount of work or research done on the power supply. A lot of the magnetism is lost because it's not contained, and exactly how to contain it, I don't know. I mean, the magnetism should really all be focused in towards the tube to drive this ball, but a lot of it is just going out towards the outside where it's not useful, and I suppose that is the main problem with this design. Yeah, I don't know how to fix that right now, and I couldn't think of anything right in the last few days after I received after I got the briefing from the engineers. Perhaps you have some insights or some expertise, and maybe you could get this idea to fly. I hope someone could get inspired by this and perhaps innovate a better gas pump. Perhaps something that would push the gas pump technology forward. Thank you for watching.